Welcome. In this video, we'll be looking at the triangle inequality theorem. The triangle inequality theorem is when you add two sides of a triangle together, the sum of those two sides will always be greater than the third side. So for example, side A plus side B has to be greater than side C. Also, side B plus side C has to be greater than side A. And finally, side C plus side A has to be greater than side B. This is kind of how it works. If you notice, 7 plus 8, that's 15. That's bigger than 10. So this, of course, would make a triangle. 6 plus 7 is 13, which is also bigger than 10. So you get another nice triangle. 5.5 plus 6.5, that's 12, which is also bigger than 10. 5 plus 6 is bigger than 10. So you still get a triangle, but 11 is just barely bigger. So the triangle is getting a little shorter. 4.5 plus 5.5, that's exactly 10. And so you don't get a triangle because those two sides have to be greater than and not just equal to. And finally, 4 plus 5 is 9, and since 9 is not bigger than 10, it won't even join together. So let's see if the triangles can have the following lengths. And while it's good to always check all three inequalities, the ones that are most important when you're checking to see if it's true is to check the two smallest sides to see if they're bigger than the third side. So your two smallest side on this is 3 plus 7. So 3 plus 7, that equals 10. And 10 is greater than the third side, which is 8. So this would be a triangle. On this one, we'll take our two smallest sides, so 3 plus 6, and we're going to see, is that greater than 10? Well, 3 plus 6 is 9, and 9 is not greater than 10. So these lengths actually could not form a triangle because the two smaller sides are not bigger than the third side. Try this one out real quick. See if these three lengths would form a triangle. So my two smallest is 2 plus 7. Well, 2 plus 7 is 9. Is 9 greater than 9? Well, 9 equals 9, but it is not greater than. So this would actually not form a triangle. Okay, so not only can we test to see if it'll form a triangle, but we can actually find a range for our third missing side. So two sides of a triangle have lengths 8 centimeters and 10 centimeters. What are the possible lengths for the third side? So on these, we need to set up our inequalities. So we take our first two sides, 8 and 10, and we say 8 plus 10 must be bigger than our third side, which is x. Well, we can also say 8 plus our third side, x, has to be bigger than 10. And the last way we can arrange this is 10 plus x has to be bigger than 8. Well, if you think about this last one, if we add anything positive to 10, it'll still be bigger than 8. So we actually don't even need this last one because it's always going to be true. On here, if I subtract 8 from both sides, I get x has to be greater than 2. Then 8 plus 10 is 18, so x has to be less than 18. So my range is x is greater than 2 and less than 18. So anything between 2 and 18 would be a possible length for the third side. But be careful, we cannot actually include 2 and 18. It has to be between 2 and 18. All right, pause the video and use the same method from the last slide and try this one out. All right, let's set up our three inequalities. 20 plus 35 has to be greater than x. 20 plus x has to be greater than 35. And finally, 35 plus x has to be greater than 20. Now, no matter what I add to 35, it'll still be bigger than 20 because 35 is already bigger than 20. So here I get on this one, 55 has to be greater than x, so x is less than 55. If I subtract 20, I get x has to be greater than 15. So my range is x is greater than 15, less than 55. So anything between 15 and 55 works. All right, let's talk about one last thing, the relationship of sides of a triangle to the angles of a triangle. In this triangle, the largest angle is 120. So the largest angle is always across from the largest side. So this side right here would be the largest side because it's across from the largest angle. The medium angle, in this case 40, is always across from the medium side. And finally, the smallest angle, 20, is always across from the smallest side. So while I might not know the lengths of each side of the triangle, I know which one would be the smallest, the middle, and the largest. So look at this, take a second and see where you label smallest, medium, and largest. Okay, so your smallest angle is 30, So the side across from 30 is right here. Your middle angle is 50. Side across from that is right here. And your largest angle is 100, and the side across from 100 is right there. Okay, so this is a nice little word problem. Once again, try it out on your own. Okay, so you're a landscape architect designing a deck. You want to place the lounge chairs in the two biggest corners. Where should they go? Well, they should be across from your two biggest sides. So if 27 is your biggest side, B is the biggest angle, and the 21 is your second biggest side, so C is your second biggest angle. So they should go in the corner of angle B and angle C. List the angles from smallest to largest. So on all of these, I'm going to go through them kind of quickly. Pause the video if you need to and try them out. Your smallest angle will be across from the smallest side, which is 5. So that's angle R, followed by angle U, and finally followed by angle F. Listing angles from smallest to largest here. Your smallest side is 4. So the angle across from 4 is angle A. And then, you have 6, because this is an isosceles triangle. So angle C and angle P are actually congruent. So those would be the same size. Here, if you're listing from shortest to longest, you'll notice all the angles are the same. So this triangle is actually an equiangular triangle, which makes it also equilateral. So all the sides will actually be the same length. So there's no shortest and there is no longest. All right, here's one that we can actually list now. We're going to list the angles from smallest to largest. So my smallest side is 68.5. That goes with angle N. Followed by 86.5, which goes with angle O. And finally 100.2, which goes with angle M. Let's list the sides from shortest to longest now. So now we're going to talk about sides. So let's identify our shortest angle, our smallest angle, which is 33 degrees, and that's across from BW. Followed by 44, which is across from BI. And finally, 103, which is across from IW. So BW, BI, IW in that order, from shortest to longest. Okay, sometimes you have to find the missing angle, so we know a triangle adds up to 180, so this will be 55. And then we can list the sides from shortest to longest. DR, DA, and finally AR. And I think you probably get the concept. The last one, you'll notice it's a word problem. You'll want to draw a picture. Angle A is 70, B is 2x minus 10, and C is 3x plus 20. We know that the angles of the triangle add up to 180. And so you solve for x first. 70 minus 10 is 60, plus 20 is 80. So plus 5x equals 180. Subtract the 80. Divide by 5, so x equals 20. And if you plug those in, you get 2 times 20, which is 40 minus 10, so 30 degrees. 60 plus 20 is 80 degrees. So the longest side will be across from the biggest angle, which is 80. So AB would be your longest side. Thank you for watching.